Hey there, in this video I'm going to talk about Monte Carlo methods. Monte Carlo is a technique for solving problems where you simulate a set of rules many times in effect to see what happens. This will let you calculate statistics for very complicated systems. This will let you model a physical system following some underlying laws of physics. And we're going to look at a couple examples in this video. Now, both of these examples could be done using other methods. They're only here to serve as examples. So in the first case, we're going to do a calculation from the game poker, and we're going to calculate what are the odds of being dealt a flush in the game poker. So you get a hand of 5 cards. What are the odds that all 5 of those cards are from the same suit? In the second example, we're going to calculate the value of pi by throwing darts at a virtual dartboard. So since these are more complicated problems, I'm going to outline what I want to do by writing comments, and these comments will serve as structure for my code. In the first case, I want to calculate the odds of a flush in poker. So to simulate a game of poker, I need to create a list of cards. So what are all the possible cards in a deck of 52 cards? So we've got the cards ace through king, and then we have the 4 suits, hearts, diamonds, clubs, and spades. So I want to write some code to do that, but before I start doing that, let me also outline the rest of what we're going to do. So we're going to create a list of cards, and then we're going to repeat a bunch of draws from that list of cards to see how many flushes we get. So we're going to call our number of repetitions m, and we're going to set it to a large number. We'll have to see how large it needs to be by trying different values. And so repeating lots of times, that kind of implies I want to make some kind of for loop. And in that loop, I want to draw cards, 5 cards to be a poker hand, and not just draw 5 cards, but they need to be unique cards. It's impossible to draw the ace of clubs more than once from a deck of cards. So that's kind of what makes this problem a little bit trickier, is we can't draw the same card more than once. So we're going to draw 5 unique cards. And then we're going to check to see if those 5 cards are a flush. Usually they're not going to be, but occasionally they will be, and then we want to keep count. How many flushes do we get? And then once we have the count of how many, and given the total number of repetitions we have in our loop, that'll let us calculate what fraction of dealt out hands are going to naturally be flushes. So we will be done with our loop, and we'll just print the result. So that's the outline of the code I'm going to write. Now let's fill in the details. So the comments here help me break up a harder problem into simpler pieces. And so right now, the only thing I'm worried about is how can I create a list that contains all the cards? Now, thinking ahead, I want to be able to identify later on, are they the same suit? Are they hearts? Are they diamonds? So the way I identify the cards needs to make them easy to check. So what I'm picturing here is I'm going to create a list named cards, and it's going to have things like 2 of hearts. So I can use like the capital letter H to represent hearts, or it might have, let's say we had the king of spades. Okay, so I'll use like numbers for the card values, maybe add in the letters A, J, Q, and K for the face cards. And then for the suits, we'll do H, D, C, and S. And so I think those should all be, those will all be unique. So that would be, we can, with 2 characters in a string, represent each card. Now, I could type out all 52 possibilities, but that's effort. I don't want to do that. I want to write code that does it for me. So I'm going to start with an empty list, and I'm going to use a for loop, actually 2 for loops, to fill in the list for me. It would also be possible to do this as a list comprehension, or part of this is a list comprehension. But just so it's, what first came to my mind is to use a for loop. So we'll start with that. We can always go back and make the code more efficient later. So I want to loop through the different suits. So we could do a list of strings, but what would actually be a little bit quicker is if we just make a single string. So if I have a for loop operating on a string, what it does is it just goes through letter by letter. So the letters will be hearts, diamonds, clubs, and spades. And then I want to run through the values of the cards. So we'll do for value in ace, 2, 3, 4, 5, 6, 7, 8, 9. Tempting to write 10, but that would actually kind of break things because that would be a 1 and a 0 as separate strings. So we'll just call it 0. We'll have to like remember that 0 means 10. And then we have the face cards, Jack, Queen, King. Okay, so these two for loops will now iterate through all the possible cards. And as we go through, we're going to append onto the list we made. What we're going to put in there is the string that represents the value, appended onto that the string that represents the suit. So that'll give us things like 2H for 2 of hearts. Now let's make sure that code did what I expected. So we're going to run it, and then we're going to print the cards just to see what we get. So that looks pretty promising. So I've got my hearts starting at ace, 2, 3, queen, king. Yeah, it looks good. So now we are done with that part of the problem. I don't have to worry about this at all. Next thing I want to do is the second part here, where I'm going to repeat many times. Okay, so that's just screaming out to write some kind of loop. And I know how many times, or I'm going to control how many times I loop by setting n to some large number. Let's just set it to like 1,000 to start. So we can do, say, for I in range n. So now our task is to draw 5 unique cards. And this is the hardest part. This is what I spend most of my time thinking about with this problem. It's easy enough to draw a single random card. Well, we can do that with random.choice. But how do we make sure that we aren't trying to draw the same card more than once? Because that would be impossible in a real poker game. But if we're just picking random things out of a list, randomly you could end up picking the same thing more than once. And if we let that happen in our simulation, not only is it not realistic, it could possibly skew the results of the odds of a flush. See, the issue is, let's say you have your first card's a heart. And so then the question is, will the next 4 cards also be hearts? Well, as you draw hearts out of the deck, there are now less hearts to draw from. And so it's not quite as simple as saying that the odds are 1 in 4 times 1 in 4 times 1 in 4. It's a little bit more complicated than that. So let's say we want to draw a hand of cards that's going to have 5 things in it. So we'll start with an empty hand of cards, and we'll start storing the cards in there. And we want to sort of build our code around the while loop. So while the length of my hand of cards is less than 5, then I haven't filled it in yet. And so what I want to do then is I want to draw a card, and I'm going to get that with a random.choice out of cards. And I want to make sure that that card is not already in the hand. So we're going to use a second while loop. The first while loop was to fill in the hand. The second while loop is to check for legal results. And if the result is not legal, it just keeps regenerating results until something is legal. So what we could do here is like while card in hand. So this would happen if the card was already in the hand. In that case, we want a new card. So the point of this code is to redraw duplicate cards. If we back here at this line generate a card that's not already in the hand, the while loop won't evaluate true, so it won't run at all. But if we do draw a duplicate card, then it's going to start drawing new cards, and it's going to be stuck in this while loop until it creates a card that isn't in the hand. And so then once we are successful, we can append that card into the hand. Okay, so that should work. That should start building us hands of cards. So let's try out this code. Let's start with just 5 iterations, and let's print out what kind of hands we can get. And so we'll just do a quick check here just to make sure I don't spot any duplicates. So it looks good. And we'll run this a couple times just to make sure Certainly it's drawing 5 cards. It's not crashing. You know, we're already 90% of the way there. Just want to make sure we don't have any duplicates. Yeah, I think we're all right. So now that task is done. We can create a unique set of hand of cards. So now the next is we're going to check for a flush, and we're going to count how many flushes we have. So the way we check for a flush is to see if the suit, that's the second letter in the strings, are all the same. So let's see, maybe there's a more compact way to write this, but I guess what I'm thinking is we just step through the hand step by step. So if hand 0, that would be the first card in the hand. And if I look at the last letter in that string, so here this would be hand 0 would be this first line here, and the last character in there would be D. I want to check, is that equal to hand 0 or hand 1, last character? So in this case, D is equal to D. Is that equal then to H, C, S? I mean, so in that case, it'll fail at the next comparison, but eventually, somewhere after generating enough of these, we should have a flush, and it should say, yeah, that's true. So we want to, let's just kind of copy this because we're going to write a bunch of these. So if the first card is equal to the next card is equal to the next card, and so on. I kind of feel like we could write this in a more compact way with like another for loop. But on the other hand, there's only 5 of them, and so it would take me longer to figure out how to do it than it did to type out these 5 options. And so if these are all equal, then that means we have a flush. So we want to increment some kind of flush counter. So we'll say flush plus equals 1. We need to then initialize how many flushes we have. So we'll start with 0, of course. And then while I'm up here, let's put the total number of runs back up to 1,000. Okay, so then the flush counter will count up. And then we are done with our for loop, and so we just want to check what's our answer. So we can print out some kind of nice message. We'll do a formatted string, something like odds of flush equals, and then we'll do a calculation here in the curly braces. So what I'd want to count there is the number of flushes I have divided by the total number. Let's make it a percentage. So I'll multiply by 100, and then we'll just print a literal % sign afterwards. So now, moment of truth, let's see if it works. Of course, the good news is we've been testing as we go, and we've been compartmentalizing our hard problem into simpler pieces, so I'm really just checking this part right here. And I guess I got something wrong in that part right there. List index out of range. Okay, 1, 2, 3, 4. Yeah, I got carried away. So hand 5 would represent the 6th card in our 5-card hand, so that's of course illegal. But I knew right where to look. I mean, not only does the error message point, but I know that my code worked up till this point. I've been testing as I went. So no big deal. We'll just make that correction. It says odds of a flush 0.1%. Run that 0.1, 0.1, 0.4, 0.0. All right, so it's not that the method is broken. What it's telling us is that we don't have enough precision. We haven't tested enough hands. Flushes are rare enough that just running 1,000 simulations doesn't really make it clear how often we see the flush, just that it's not very common. Let's try 10,000. Wow, we're really jumping around still with 10,000. Try 100,000. Of course, it takes 10 times longer to run that. Looks like the odds of a flush are about 1 in 500, which actually that agrees with the result on Wikipedia, so that's a pretty good sign for us. The very last thing I might want to do here is, you can see it's printing out a bajillion sig figs, which I don't really think looks that good. Let's just drop it down to 3 sig figs. So after the colon here is a formatting string, make it a float with 3 decimal places. And we'll call this the final result. So 0.17, actually, that looks kind of different than the others. We might even want another 0, depending on how patient you are. Looks like we're around 0.2. So that's some simple Monte Carlo code for us. If you still have some patience left for this video, we're going to try another example now. in this second example, we're going to try and calculate pi by throwing darts. On this particular version of Monte Carlo, you literally could do by hand if you had the dartboard and the darts and enough patience to throw them, but we'll just simulate it in our computer. Okay, so steps here. First thing I want to do is I want to draw my virtual dartboard, mostly just because I want to talk about how this algorithm is going to work. I'm going to draw the dartboard, and then I'm going to outline the other steps. So first thing while drawing is I want to use plot.figure with a fig size to make a nice big image. We're going to make it look pretty cool, so we'll make it a bit bigger than normal, but we'll also make it square. And then in my drawing here, what I want to draw is a circle circumscribed by a square. And what we're going to look at is the ratio of darts that land inside the circle compared to the total number of darts that could hit anywhere in the larger square. And we're going to use the area of these shapes to do our calculation, or as the basis for our calculation. So I'm going to do a little bit of drawing with matplotlib. I'm going to draw a circle using plot.circle. I'm going to put the center of the circle at the origin. I'm going to make the radius of the circle equal to 1, and then I'm just going to set its color. So I'm going to make its edge color black. I'm going to make its face color transparent, which you represent by typing in the string none, not Python none with a capital N. That would be interpreted as use whatever default you want, but we're going to use the string none. So that's my circle, and then I want my square to be drawn just along the outside of that circle. So we'll use a plot.rectangle to draw our rectangle. The first argument here is the bottom left corner. So I want that to be at -1, -1, so that it'll line up with my circle. I want it to have a width of 2 and a height of 2. And then I want to do the same kind of coloration. So I just want the outline. Do an edge color of black and a face color of none. Then to draw these things, we need to add them using add patch to an axis. So the quickest way to get an axis is to call get current axis, which will actually make one for us. And then we can add patch circle, add patch rectangle, or I guess square, where I called it. Okay, so then we're going to have some other Monte Carlo code here, but when we're done with everything, we want to draw it. And I want to try drawing it right now just to test. So we're going to set, first of all, the axis to scaled. And I don't really, I mean, we want to run this code, so I don't want it to be a comment. This will just be in the category of, show result. So we'll do a plot axis scaled, and then we want to, I think it'll look cool if we don't draw the X and Y axis, we just draw the circle and the square. So we'll turn the axis off after I scale it, and then we'll show it. Okay, so here's our picture. It's our dartboard. And so the idea is I'm going to randomly generate darts somewhere inside the square, and some fraction of them will also be inside the circle. Now here's the idea. This is a unit circle, it has radius 1, and so the area of this circle is pi. This is a square that's 2 by 2. You can even see that up here when we set the width and the height. So it's 2 by 2. It's got an area of 4. And so the fraction of darts that land inside the circle divided by the total fraction of darts should be equal to pi divided by 4. So actually, let's keep track of that result here. So fraction inside circle is pi on 4. And so by counting darts, we can now calculate pi. So now we're going to need to think about how we're going to generate darts. Okay, so we're going to generate n equals many darts. And we want to generate them inside the square, which includes the circle. And then I want to check which or how many darts are inside the circle. Okay, so that's the basis of my algorithm here. And so now let's think about this step by step. First of all, I want to generate a bunch of darts inside the square. So what I want to do is create a pair of random numbers, one to represent x and one to represent y, and then I want to make many of these pairs. We could do this with for loops, but in this case, I think it'd be good to try out using NumPy, because NumPy will let us generate entire arrays of random numbers. So let's start with, say, n equals 1000. And then to generate an array of x values, we do np.random.rand. This will give us what are called uniformly distributed random numbers ranging from 0 to 1. And it'll give me n of them. So numbers ranging from 0 to 1 would be like just this part of the circle. So I could do just this part of the circle with x and y. And we could make it work. We would basically just be working with a single quadrant and exploiting the fact that this picture is symmetric. But let me show you a trick that'll let us generate the random numbers in a bigger range. I want to generate random numbers for x that range from -1 up through +1. So first of all, that is twice the range that we would normally have. Instead of having a range is spaced 0 to 1, I want a range that's spaced 0 to 2, and then I want to shift it leftwards, which is the same thing as subtracting 1. So this 2 times our random number minus 1 will give us random values -1 to 1. Let's just try some values in our head. So the smallest value that this could generate, the rand here could generate, would be 0. 0 times 2 is 0. Subtract 1 is -1. So that's the leftmost limit. The biggest value that rand could generate would be 1. 2 times 1 is 2. Subtract 1 is 1. That's this upper limit. And if we generated 1/2, 2 times 1/2 is 1, minus 1 is 0. That'd be the middle. So by multiplying and subtracting, we can adjust our random number range. That's a pretty common trick. In a follow-up video, we'll go into more detail about other kinds of ways to deform this range that we're generating our random numbers from. So we're going to generate a random array of x values, a random array of y values. The next task here is to find out how many of these darts are inside the circle. So again, we could use a for loop and check each step by step, but we could also use arrays to do this much quicker. So let's calculate the radius, or the radial coordinate of these points, how far they are from the origin. And then we can just see, is that radius less than 1 or not? So to calculate this r for the arrays x and y simultaneously, we can just do numpy.square root x squared plus y squared. So this will calculate an entire array of radial coordinates for our points. So now we have to count how many of these are less than 1. Once again, we could use a for loop, but there's a quicker way. Let's use some fancy array comparisons here. So I want to check or make a list of what points are inside. A point is inside if its radial coordinate is less than 1. And a point is outside if its radial coordinate is greater than or equal to 1. Now, as far as the equal, do you want to put the equals for the inside or the outside? Strictly speaking, you really shouldn't have any points that are exactly on the border anyway, so it really shouldn't matter. But you just want to make sure you're not double counting. So you don't want to have both of these be equal or neither be equal. I don't know if the parentheses are actually necessary here. I just think it helps for readability. And so this is going to create, each of these are going to be arrays of true-false values. And so we're kind of at counting how many trues or how many falses do we have. But even better than that, we can do fancy stuff like slicing. So if I do something like x and I slice it with inside, this is now just an array of x values that are inside. So we could plot those. So let's plot just the points that are inside the circle. So that would be x inside, y inside. And let's draw those with red dots. Let's see what that looks like. So this will test a few things for us. First of all, is it showing correctly that the points are inside the circle and not somewhere outside? Yes. We probably should do another test to make sure that we can generate points in the entire range, or make sure that the points that are outside are really where they're supposed to be. So let's just add a second line here. So if we're outside, let's make them a different color. I think by default it would pick blue, which I don't know. I think I want to do gray. So I'll do color equals gray. The reason I didn't do like G dot here is because that would be green. And I don't know if there is a single letter version of gray. Maybe there is, but I don't know what it is. So I'm just going to explicitly say color equals gray. So now let's run that again. There we go. So we can see we are generating points both inside and outside the circle. The ones that are inside and the ones that are outside have been properly separated. And now we just have to finish off our calculation. The graphing here is just kind of for visualization's sake. This didn't actually calculate anything for us. The calculation we want to do here is how many are inside versus the total. So the value of pi here is going to be equal to 4 times the length of points that are inside. So that would be the length of, we could say, x inside, y inside. Let's do r inside. And then I want to divide that by the total length, which we called capital N. And then let's print our result somewhere. So let's make it the title. So plot.title, and we'll use a formatted string here. Say pi equals pi. See, what is pi equal to? 3.16. Yeah, that's about right. Of course, if we run this multiple times, we're going to see our value kind of dances around. If we want to get a higher precision, we need to boost the value n. That will slow down our code, but it'll give us something more accurate. It's still going to dance around, but you can see, we're a little bit more stable here. Now, as it so happens, this is like one of the very least efficient ways to calculate pi. So you would need a really huge number of points and a long time for your computer to get an accurate value of pi using this. But on the other hand, it's a pretty simple technique that you could, in principle, do by hand by throwing darts at an actual dartboard and counting how many hit. That of course assumes that when you throw darts that they hit randomly. So you have to be really bad at darts like me. So you're really bad at darts throwing them at your dartboard, then this would be a good method. If you're really good at darts and you always hit the middle, then that would not be a uniform random number. And that's actually kind of the point of a follow-up video here, is what if you intentionally want random numbers that are not uniformly spaced? How do you make that happen?